Hello and welcome everyone. So in this video, I'm going to talk about deadweight loss and externalities. Eventually, I'm going to talk about how to find deadweight loss on the externality graph, whether you have a positive or a negative externality. First, I'll talk a little bit about deadweight loss generally and then externalities generally. So economists use deadweight loss to talk about the inefficiency that enters into a market transaction. So usually we have a situation where buyers value the good more than sellers. It costs sellers to produce it. So there's economic value generated. And if for some reason those transactions don't take place, then there's an inefficient amount that actually gets traded. We say there's deadweight loss in that market. That can happen if you have like a monopoly operating, or if there's a price control or something like this. You have a situation where whatever is the units of the good, consumers value them more than they cost to produce, but they end up not getting produced, not getting traded. And so we think of deadweight loss as the foregone or the lost potential economic value. With externalities, we're thinking of a situation where the original decision makers are paying attention only to their own private benefit and their private cost, but there's spillover effects on bystanders. Got to be bystanders. If there's no bystanders, there's no externality. But if we do have bystanders and there's a spillover additional benefit, we have a positive externality. Or if we have bystanders and there's some spillover harm that affects them, we'll call that a negative externality. What ends up happening is this compromises efficiency, because the market left to its own devices is going to lead to some equilibrium. And in the negative externality situation, the original decision maker is going to pay attention to their benefit, their costs, and say, good, that's the amount that we'll produce. The problem is, at whatever is that market quantity, there are additional costs that they didn't pay attention to that are affecting the bystanders. So we get an inefficient level of production from the perspective of society as a whole. In particular, if you have a negative externality, we get overproduction. We get too much of whatever is that thing because it's not accounting for, the decision makers are not accounting for the higher costs that are incurred by society. In the case of a positive externality, the bystanders are benefiting, but their benefits are not brought forward, are not considered by the decision makers themselves. The decision makers pay attention to their costs. As long as their benefits exceed their costs, they keep producing more. When their benefits exactly equal their costs, they stop. But at that point, there's still additional spillovers that are benefiting bystanders. And so from society's perspective, they should do more. The problem with the positive externality situation is we get underproduction. We get too little of whatever is the activity. Okay, so I'll show how to graph this, and then I'll show where deadweight loss fits in and why. As I had kind of cut off here, sorry, here's my graphical depiction of the positive externality. So we've got price on the vertical, we got quantity on the horizontal, and I've drawn the supply curve labeled as marginal private cost and demand curves labeled as marginal private benefit and marginal social benefit. Remember, supply is actually just capturing marginal costs. So we say like the theory of supply is the theory of marginal cost. Well, here the relevant costs are the cost to the decision makers. So it's the marginal private cost. Demand is going to capture marginal benefits. The vertical height of a demand curve is the marginal benefit to buyers, always. And so here, though, the relevant demand curve is going to be the marginal benefit to the decision makers, the buyers themselves, but then also the spillover benefits to the rest of society. So that's why there's a higher demand curve, or a rightward, looks like a rightward shift. It's not exactly a rightward shift, because the second demand curve, what that's actually doing is just accounting for the greater benefits that are accruing to those other than the decision makers themselves, to the bystanders. What happens is the market left to its own devices is going to generate this equilibrium, this Q star. That'll be the market quantity, the competitive equilibrium quantity, and it's inefficient. It's too little. Here's the efficient quantity, QE. This is corresponding to the intersection of marginal social benefit and marginal private cost. So this is the socially efficient quantity. And the problem with the positive externality is we, from society's perspective, want this quantity to fully capture the benefits that are spilling over to bystanders. But the decision makers, the primary decision makers in the market, they're going to stop right here. They're going to pay attention to their private benefits where that crosses their private cost, and then they're done. But from this point, there's an externality. Actually, this vertical height here is this additional benefit that would be affecting our bystanders. Matter of fact, if I would have drawn this all the way out, you could calculate the externality as the difference between these vertical intercepts. Because I intend for these to be parallel lines, it's the same vertical height all the way down to here. Okay, what about the negative externality? So that's this situation where we have, again, price on the vertical, quantity on the horizontal. Here I've got the demand curve written as marginal private benefit, because that's what's relevant, is the benefits to buy or to the decision makers. Marginal private cost, this is like the original supply curve, and then the supply curve, the marginal cost curve that's going to capture, they're the same thing, that's going to capture the spillover cost to the rest of society is higher. It's indicating there's greater cost. Like it's not really a leftward shift to supply, but one of our supply shifters is a change in the price of input costs. If there's higher input costs, if there's higher costs incurred than what the decision maker was originally paying attention to, we would leftward shift supply to capture those higher costs. Well, in some sense, that's what this is doing. This is saying, here's the costs, the input cost to sellers. If we paid attention to the additional spillover costs, we'd actually have this as our marginal cost curve. So that's my marginal social cost curve. Here's my marginal private cost curve. When the decision makers come together and decide how much to transact over, how much to buy and sell, that's going to be Q star. This is the this is the market quantity, the competitive equilibrium quantity left to its own devices. This is what we're going to get. And what happens is the decision makers are only paying attention to their own costs. They're ignoring the spillover cost to bystanders. The vertical height right here is the externality. That's the same distance right here. And the efficient quantity is lower. We get inefficient overproduction with the negative externality. We should be all the way back here. If we paid attention to these much higher costs, we'd produce a lower quantity. All right, so, but what about deadweight loss? So let me scroll down here. In the positive externality case, we're going to look to find where the private benefit crosses the private cost. That's going to be my market quantity going straight up to the marginal social benefit curve, gives me the top corner of my deadweight loss triangle, and then it's made up by the rest of the marginal social benefit curve. So I've got it labeled right here, DWL, that's deadweight loss. Why? Why is deadweight loss there? Well, remember what I said initially. Deadweight loss is capturing the situation where there's additional benefits above and beyond the costs, but those units aren't produced. That's what happens here. So we stop at this quantity, or the market does, right, left to its own devices, but actually the efficient quantity is all the way out here. And this deadweight loss triangle is capturing the fact that, sure, yeah, the marginal social benefit is higher than the marginal private cost, indicating that there's additional value that could be produced if only we were to increase our output from Q star to QE. So that's why this is deadweight loss. All right, so what about in the negative externality case? Well, there's something different going on, but similar in some sense. If you have overproduction, if you were to go past the competitive equilibrium on a standard situation, a standard supply and demand diagram where there's no market failure, you get overproduction and you get inefficiency because the supply curve would be higher than the demand curve, indicating that costs are higher than the value to buyers. That's what's happening here. So the market left to its own devices is going to produce this amount right here, Q star. And the problem is, at this quantity, there's additional higher costs, right? We got overproduction. The efficient equilibrium is back here, but we've produced too much. We've gone further into the situation where costs exceed benefits, right? So think of our optimization rule. You want to stop where marginal benefit equals marginal cost. If marginal cost exceed marginal benefit, you've overproduced, you should produce less. That's exactly what happens here. Because the marginal costs, as captured, the relevant ones, by the marginal social cost curve, are higher than the marginal private benefit curve. I'm not going to edit that out. And therefore, we have deadweight loss, because the costs exceed the benefits. To improve efficiency, we'd actually want to produce less. We'd go back to here, QE. At this point, marginal social benefit equals marginal private benefit. Okay, so deadweight loss is just this triangle here. One question I should answer that maybe you've thought of that I hadn't previously said anything about, why do I have MSC and MPC and I only have MPB here, and why on this one do I only have MPC? Well, the issue is the marginal private cost curve is sufficient in my positive externality case because there's no additional negative effects on bystanders. So I don't need to have a separate marginal social cost. In some sense, actually, I could probably even edit this because I've got this right here. Sure enough, marginal private cost actually is the same as marginal social cost in this example. Oh, I didn't capitalize that. How about that? Right. And then right down here, sorry, you probably hear me clicking and typing. It's probably really loud. Sorry about that. I did not think this through. Otherwise, I probably would have done something different. Again, sorry, probably not going to edit this. Oh, I said marginal social cost. Should I edit that out? I probably should. I'm not going to. Marginal social benefit. The idea is because there's no there's no positive externality here, only a negative externality, I don't need to have a separate social curve. The private curve is enough to capture it. Okay, so now what I've done in this video is I've shown just the depiction of the standard externality examples that we would see at the principles level, where we're thinking about a positive externality and we're modeling this additional spillover benefit, or we're modeling a negative externality, we have this additional spillover cost. Okay, cool. I hope you enjoyed the video. I'll see you next time.